Hi everyone. Nice to have everyone here, and thanks for joining this PVtech Tech Talk webinar. Today we're with PVcase, which is a Lithuania-based solar software provider which helps corporate and industrial customers to optimize the design of their rooftop solar installations. We're also going to be hearing from Engie, a global power provider located in over 30 countries, committed to accelerating the transition towards a carbon neutral world through reduced energy consumption and more environmentally friendly solutions. Before we start, some important housekeeping. After the webinar finishes today, we'll make it available on the PVtech YouTube channel in the near future. We'll email you to let you know when it's available on the on-demand section, on-demand webinar section, I should say, of the PVtech website. During the webinar, please don't be shy. Feel free to ask questions using the questions function on the right-hand side of the screen, and we'll do our best to answer as many as we can in the Q&A section towards the end. Any we don't get to, PVcase can answer for you directly afterwards if you just give them your contact details. So, according to research from Solar Power Europe, 49% of the total solar capacity installed in 2022 was on rooftops. Alongside this, the C&I solar sector is growing fast as more and more businesses look to install solar on their rooftops, either to meet their own decarbonisation targets or to take more control of their energy consumption and bills as the price of solar power continues to fall. Alongside the opportunities that this growth presents, scaling up the rooftop industry poses challenges. Businesses and asset owners will need to make sure that their solar installations are properly designed and optimised if they want to get the most out of their investment. Software solutions, like those from PVcase, can help overcome these challenges by improving the way solar panels are simulated and modelled, optimising system designs, maximising energy generation, and increasing the efficiency of the engineering teams installing them. So today we're going to be hearing from Tadas Banzevicius, Technical Sales Manager at PVcase, and Heidi Hansen, Sales Technical Designer at Engie. We'll be hearing about the factors driving the growth of commercial and industrial rooftop PV plants, how to improve the efficiency, accuracy, and quality of commercial and industrial rooftop PV design using specialised software. And then we'll watch a real-time demonstration on the design of industrial rooftop PV projects. Heidi will speak first, followed by Tadas with a software demonstration and some back and forth between the two of them. After that, we'll conduct a Q&A session with some questions from PVtech, followed by any audience questions that you put in the box. So remember, put those questions in the chat box throughout the webinar, and we'll get to as many as we can. So enough from me. Over to you, Heidi.
Thanks for that introduction, Will. So, as he said, I work with Engie, and I work in their North American branch dedicated to solar and battery storage in the commercial and industrial sector. So the C&I industry has really been growing in the past couple of years, and that is due to many reasons. One of the largest motivations for these companies to do solar is that many of them are setting sustainability and carbon reduction goals. They're trying to reduce their carbon footprint, either to give themselves a better public image or so that they can contribute positively to the environment and they can feel good about one thing that they're doing. And many of these companies are setting these goals for 2025 or 2030. So that's when we jump in and we offer to put solar on any of their large distribution centers. And that has been a huge motivator for companies to do solar right now. Another one has been that utility rates have just been slowly increasing, which means energy prices have been increasing. And so many companies are looking for ways to get a fixed price for energy, and they can do that through solar. So a lot of these companies have several distribution centers throughout the country and a large power usage each year. So if there's any way for them to get a fixed price on that and not be worried about that price increasing in the future, they definitely are interested in that. One other reason I'll talk about, but will admit I don't have a lot of knowledge on as an engineer, is that in the US, the IRA was recently passed, and this has extended federal tax incentives, which really motivates the customer. So even if it's a company that isn't too concerned about reducing their carbon footprint, isn't too concerned about their public image, if it's going to be able to help them financially, that makes them interested. So that's a whole nother section of C&I that we can do business with. So now I will talk a little bit about what Engie does and specifically what I do within Engie. So we do all of our design and build in-house. We have our own structural, electrical, and civil engineering teams that I personally work with a lot. I work on our pre-construction team. So when we're bidding on projects and trying to win portfolios, that's when I come in. I'll be doing all of the design work and running any analysis on what the production is going to look like. So I'll talk a little bit about some of the challenges we're facing in the industry right now. One of the biggest challenges is just making the economics of projects work. The price of energy is low in many states, but the cost of equipment and labor just continues to rise and rise, making it harder to make the economics of projects work. So that has been a challenge that we work on and are trying to mitigate. One challenge that I'm sure everyone has been experiencing is the supply chain issues. So one way Engie has been trying to mitigate that is by developing our advanced procurement team. So that team has really grown in the past couple of years, and their job essentially is to put in all of these orders. We're trying to get all of our electrical equipment that is experiencing these long lead times. We're trying to get that ahead of time. So we're putting in orders for modules, inverters, transformers, anything else that has these long lead times, and we're storing them safely in one of our storage units. So then when one of our sites is ready for construction, ready for this material, they can have it immediately. And this way there's no sites just sitting around waiting on material, waiting to start construction, waiting to start operation just because of long lead times. So this has been a relatively successful method. It's not a foolproof plan. Obviously, there are still issues, but this has really helped Engie mitigate these issues and keep our construction timeline on track. Something I have a lot of experience with on the pre-construction side is our competition with other developers. So it is the Engie strategy to, even at this preliminary stage, create as accurate of a design as possible and as accurate of a budget as possible. So I am looking at all the obstructions on site, how tall they are, what kind of shadows they're going to produce, any offsets that we need to adhere to, and I'm trying to make my design as accurate as possible. Whereas I've noticed that with some other developers, they will start the bid with a super low budget, knowing that it will increase later, and they won't necessarily consider all of the shading effects or offsets, so that their system size looks really big and wonderful. And so we really just need to depend on people knowing the Engie name and trusting that we are going to deliver these high quality projects while still maintaining safety and trying to keep our cost as low as possible. One other issue I experience a lot is just our quality or quantity of projects and keeping those timelines on track. So each project needs to go through several people and several teams within my business unit, and it starts with me. So I need to make sure that my design process is really efficient and effective. So we're proposing over 200 rooftop sites a year, and that's just rooftops. We also propose ground mounts and carports and battery storage projects. So I need to make sure that my design process is as efficient and effective as possible so that we can be successful. And that has really been where PVcase has been helpful to us. So there are numerous benefits of using PVcase roof mount, but I will just go over a few of them right now. One thing is it is a huge time saver. I would say the average rooftop layout probably takes me about half the time it used to now that I'm using PVcase roof mount, which has been a huge help. I'm able to design several rooftops in a day now, whereas it was most likely just one rooftop I was able to put out a day before this. And another thing is I feel there's an increased accuracy with using PVcase, so I'm able to feel more confident in my drawings. And one reason of that is because of their shading tool. So they automatically, you're able to input the location of your rooftop, the size of your obstructions, the height of your obstructions. And so it automatically takes all of that into consideration when estimating the shading effect and estimating where the shading is going to be on the rooftop. So I feel that adds an increased accuracy to my drawings. It makes me feel more confident and obviously leads to less redesign down the road. On the topic of redesign, PVcase does make it very simple. More often than not, I'll need to go back into a rooftop I've already designed and maybe change the spacing or change the size. And with PVcase, this is a half an hour task. I'm easily able to go in, change a couple inputs, and re-input all of the modules onto my design. So it has made that process so much more simple and quicker. One other feature that has been really helpful that I don't have as much experience with is the electrical design feature. So as I said, we have our own electrical engineering team that has their own process, but with this feature, I'm able to give them these preliminary estimates on cable work or stringing work, and sometimes when they are too busy and their workload is very heavy, I'm able to do a very simple stringing project of a rooftop because I am not an electrical engineer and I'm not familiar with that, but using PVcase, pretty much anyone could string a rooftop. It makes it very simple. And on the flip side of things, it also makes the as-built process easier. So when we're ready to put a rooftop into commission and we're ready to put it into operation, we need to go through and do an as-built process and put that into PVsys one last time to confirm what the production is going to look like realistically as it's built. And this is one simple button in PVcase. It's so simple to just transfer that straight from PVcase into PVsys, which is the software we use. And before that, the software we were using, we would experience a lot of issues and we would probably have to go in and change it within PVsys already once we had uploaded it. So to be able to just transfer it in one click from PVcase to PVsys is a huge help. So now I will talk a little bit, or I will give a couple examples of projects that I have worked on within PVcase, so you guys can see. So I'll start off with this example. It is a relatively simple roof, kind of a basic rooftop that I see often in my design process. So all I needed to do on here was go through and I outlined all the obstructions. There are several AC units, skylights, other things. So all I needed to do was go through and find those. And then using the PVcase button, I was able to see what their shading predictions would be, add height to them, and then just input my module settings, layout settings, and just essentially click my rooftop area and it filled it with modules. Once I've done this, all I need to do is go in and clean up the drawing, and that's a 20-minute process. So it has really been a huge time saver and so simple to come in and build these rooftop designs now that I use PVcase. One other thing I'll comment is you can see here that I have drive aisles throughout my array. For fire code in the US, you need to have a limit of 150 feet by 150 feet of an array. It can't be larger than that. There needs to be a drive aisle every 150 feet. So before, it used to have to be me manually going in and measuring 150 feet and then adding a drive aisle. But here, PVcase automatically does it, so that saves me a lot of time. And now I'll show you a little bit more complicated of an example. So as you can see on this rooftop, there are a ton of obstructions. There are a ton of parapet walls. There are several places where the rooftop meets another rooftop, and so it is just a mess. But more often than not, I'm having to look at rooftops like this. Maybe we will be bidding on a portfolio of several rooftops, and most of them look good, but there are a few like this. So before, I would maybe need to spend all day just trying to figure out how much I could fit on this rooftop, what it would look like. But here I just need to spend a couple hours getting all of the obstructions outlined and all of the shadows inputted. And then PVcase fills it for me. So this has been a huge time saver because oftentimes on these buildings that are so obstructed, we may not even end up bidding on it, but my sales team wants me to look at it. So instead of spending almost an entire day on a rooftop that we're not even going to build, we're not even going to end up bidding on, I just have to spend a couple hours to tell my sales team, okay, we can only fit this much on the rooftop. This is what it's going to look like. It's not worth it for us. So this has been a huge time saver and really made a difference in my workload. So those were a couple examples of how PVcase has been helpful for me. I will pass it over to Tadas so he can explain the product in a little more detail.
Okay, Heidi, thank you very much. First of all, just want to double check if you can hear me.
Yes.
Okay, wonderful. Always like to make this pre-check. So thank you very much for your part, for your presentation. It was amazing to hear what size of a project you're doing. I still have a couple of questions, if you don't mind, based on the presentation which you've done. So one of the things you mentioned that you trying, as the Engie group and as yourself, you're trying to prepare as accurate design as possible in early stage to prepare your quotation as close to like final product or like final design. Does it take into account any like iteration, or how usually you're coming up to that final layout, or we just usually just designing one approach, or you're comparing a few different layouts? Could you share a little bit on that topic, because it's quite interesting to understand?
Yeah. Many times I will do several iterations on a rooftop, and I will need to go back in and redesign. And PVcase makes it really nice where I'm able to see all of the iterations I've already done on this design. And that has been really helpful. So often I'll need to change spacing and do several iterations on that. And PVcase has been really helpful for that and a huge time saver on it.
Okay, wonderful to hear. So the other thing, what I'm also interested is it's related a little bit to the supply chain. Of course, Engie has amazing way to managing this one by just purchasing the things up front and just stocking them in your warehouse. But from your experience, how often do you need to redo even your early stage design? Because, for example, I don't know, the module supplier change, or you decided to use a different inverter, or some other things came up. So is it like often case when you need to redesign what you already done, or this is more like exceptional from the rule?
I would say it's actually pretty often. Probably about half of the rooftops I design, I'll need to go back in and do a redesign, maybe change the spacing, or we've discovered something new about the rooftop. So definitely more often than not, I'll need to do a redesign.
Okay, gotcha. Wonderful to hear. Other thing, what was quite interesting from your point of view, what you mentioned. So right now, I think in USA, the same situation we have here in the Europe, but the energy price is kind of stabilizing or even a little bit going down compared to what we have like in the beginning of 2022. So this one, of course, make for us to like look a new way how to design this one, how to design a project to make more like a price effective from, especially from a customer point of view. Interesting point is, and I think we can see this on globally in the market, that the labor or the installation cost increasing. So what I'm interested to know for you as when you are like touching the project in the first place, do you take in account any design approaches or specific like scenarios or specific way how you're designing to make the installation easier and of course more labor intensive? Or less labor intensive, not more.
Yes. Yes. I am definitely thinking into the construction phase when I am doing these design process. The way I learned to design was from our rooftop designer. So I am always considering construction and installation. One prime example of that is with rapid shutdown devices. There's been issues with them lately of catching on fire and having issues in sight. So, and that oftentimes just comes from contractors installing it incorrectly or missing a connection. So I am preemptively trying to design my rooftop so that we don't even need to use these rapid shutdown devices. And this is just preemptively trying to get rid of that risk. So I'm definitely trying to think about installation and make sure this is safe for someone to install and it's possible for them to do on our timeline.
Okay, wonderful. Thank you very much for sharing. So let me share my screen and jump to the presentation of AutoCAD. So thank you everyone for your question. I see that you're quite active in the question bar. So feel free to continue asking the question. We will try to answer as many as possible throughout this webinar. I think, Heidi, there is already one question for you. How long does it take for you to become such a good expert in the PV area? Could you share a little bit? How long did you practice? How much time you are doing these designs already?
Yes. So I would say it took me less than a month to get PVcase down. Me and my colleague worked very closely with Tadas, and he helped us understand the product. But I think it's really simple. And for any AutoCAD user, it's really easy to pick up. And once you get it down, you're able to do the process. And so quickly, it's like muscle memory.
Okay, thank you very much for sharing that. Okay, so now let's jump in to the presentation of the product itself. I think everyone should be capable to see the screen. Heidi, could you confirm that the screen is very well noticeable? Okay, so as you already understand, the PVcase, it's AutoCAD plugin. It means all the design, which we then directly in DWG file. This file could be easily shared with a user who has a simple DWG, simple AutoCAD, and we will be capable to read and see all the elements. The way how we can start the design, basically there is two main principles. The first one, we allow to import the satellite image. Keep in mind, we can also use the different metric unit system, like metric system, feet, inches. But what's most important, we can just set up a specific location where we want to import our satellite image. So for example, here we are in Lithuania in our headquarters. So we set up one of a warehouse or manufacturing facility. And this one give for us the satellite image. Of course, the satellite image, on this satellite image, we can draw as a simple AutoCAD file, let's say defining the boundaries, assigning the height of a building, and this one will be created as a 3D building. Of course, if it has like a ridge line or different slope, this one could be recreated as well. So this is one of the approach when we start design by having just a satellite image. Usually this one used in really early stage, when we don't know a lot of information or we didn't have a chance to visit the site. If you're going to more detailed stage, there is another approach when we can use the existing building boundaries. So in this case, I have a simple 2D building boundaries with some elements in it. What the software will allow for you to do is, it will allow for the user to recreate this on in a 3D manner, from 2D to the 3D. And I think this one creates a lot of value for the users because you can see and exactly understand how your project will look like. But first of all, adding the building itself, adding the parapet of a building for more precise evaluation of shading elements and the shading impact. Of course, we can set up a setback from the edges. So this one allows also to share this view with a customer, that we would have a better understanding. Also, similar elements, which usually we can find on the roof or the obstacles, could be converted from 2D elements to the 3D or just added accordingly to our predefined parameters. So always keep in mind there is a two-way how you can convert that add the elements. Also, you can define the safety path and all the similar elements which you usually find on the roof. For example, we have an AC unit. Here it is. We can define the restriction zone, the height of it, and simply pick up from the drawing. So we have 1, 2, 3, 4 of them, and they will be converted to the 3D elements. For the end, if we have entrance on the roof, we can also convert this one too. In a lot of cases, we get a question, does the PVcase work with AutoCAD LT? So keep in mind, this one is compatible just with a full version of AutoCAD because it's using the 3D elements for the design proposal. So if you look from 3D point of view, you will see that everything what created is the 3D elements. And AutoCAD LT currently doesn't have capabilities to read or understand these elements. Now, this is just the beginning of the design. It's meanwhile, first of all, we just set up how more or less our roof will look like and what kind of capabilities we will have. So let me just add some restriction zone as well here. So we're adding some area here. And now we have our roof defined. The other thing what we hate to point out, which is really useful for here, and I think a lot of businesses and a lot of engineers who is doing the design also taking in account these cases, it's shading analysis. So PVcase right now has a first shading analysis tool. Later on, we will introduce the improvement. This one will be available in less than 2 weeks. So the current version analyzes the shading based on the sun position angle. So basically, we take into account what the location will be set up of a project, what day and time will be set up, and based on that, we take the sun position angle from a database. Of course, if you change the time value here, you will see what the sun position will be adjusted accordingly. Of course, we can set up and change the date. So for example, April we set up, let's say 2 o'clock, you see the sun position angle, and this one we will cast the shading projection. If you change the time value throughout the day or throughout the year, you will see the different shading projection created, and this one automatically is created as offset area, not placing any modules. Now, to place our modules, this is quite simple and straightforward. As Heidi mentioned, we just add the module dimension in the product, so it means length, width, thickness, and the power. We adding the layout settings. So the layout settings, first of all, allow for us to set up different system. For example, flat south system, east-west system, flash mount system. This one even enable the user for the same project to define and create few different system type on the same roof. When we create the roof, we just simply generate the layout on the whole area where we didn't exclude for not placing the modules. The other thing that is really simple to do is to make iterations. For example, now we have a layout for east-west system. I just quickly adjusting few settings. Later on, I will explain in more detail why I did it. And let's see, now we also generate a flat south system on the same roof without changing anything. As you can see, it takes just a fraction of time and the layout will be regenerated. What we can see from this one and what we can already compare is to see the installation capacity, the module quantity through the layout information. So software will save each of the drawing which we've done. You can expand the list. You can see the current capacity, current module quantity. Each of this layout is exportable directly to the PVsys if you need to get the detailed energy reports. Even more, we can always regenerate the previous layout, which means you can go back and forward between a few different layouts. And this one will allow for you to store them. And even let's say the customer want to see east-west system, flash mount system, or flat south system, you can simply do everything in one AutoCAD file, in one DWG file, instead of having like 3 or 4 of them. Now about the customization of the layout itself. This one usually is quite complicated with some of the tools if you want to customize everything to the module level. So because with the AutoCAD software, we allow to customize everything to the module level. The user can select and delete the modules, you can move them around and do all the kind of changes as you would do with simple AutoCAD block elements. Now, what I didn't cover here from the spacing settings, but you can set up first of all the row spacing and the column spacing between modules. So for example, this one specifically nicely works with east-west system. On top of that, we can specify the corridors. For example, in USA, this kind of corridors is used for a fire protection. I think they have a 30 feet requirement, but every 30 feet you add an additional corridor. Here in Europe, we can do in a little bit different approach where we can use the corridor based on the module quantity. For example, we have 8 rows, 3 columns. So this one will create for us like a small subarrays, and in each of these subarrays we can place the stream. So let me show you how the result would look like. Quickly regenerate it. Now I'll get the layout of a smaller subarrays where I can nicely fit my one of the stream. Of course, once again, we can look around and just eliminate some of the modules which do not fit our needs. So this is basically how the layout creation and generation together iteration works. Is we can really quickly, easily go back and forward. Keep in mind that here we have approximately 1.5 megawatts, and it took for us less than 10 minutes to generate this layout. Now, on top of this one, the next huge portion of the software, what we can do is electrical design. So as Heidi mentioned, even if you are not an electrical design engineer, you still can do some of the electrical estimation in early stage. But if you want, you can also do it in a really detailed stage with electrical design, because we are allowing for the users to make the configuration of inverters, so it's means you can configure everything to MPPT level. So how this one is done and achieved. So first of all, we add the inverters. Inverters is defined as a really generic parameters. We are not using any database because basically we don't need that one to have. We add the inverters. Let's say on the roof, we'll have like 6 of them if needed. Also keep in mind that inverters could be placed in different locations. It not exactly has to be on the roof. You can place this one inside the building as well if needed. And in that case, you will be capable to define the height. So this simple approach will allow for you to use any inverter you want. Even if you have inverter with different size, different capacity, you can define them and add them, each of them separately. Now, just to give you examples, so we're adding all of them with the same size. The stringing, this is, I would say, where software could be really simple, but at the same time, if you want, it could help for you to make really detailed stringing. So how the stringing works in general? It works based on the string size. So we can define the module quantity per string, let's say from 20 to 24. setup, if you need optimizers to use, and what stringing pattern to use. So you can use the single row stringing. In this case, software will cover the strings which can have just a single row. Let's increase this gap. Then we can have, let's say, stringing pattern. You can also set up a direction. Is it a vertical or horizontal? Of course, each of the case will provide for you with different outputs. Software always trying to place as big string as possible accordingly to the defined settings. My preference is to use this tool usually is for the detail design. So what you can do it here, we can control maximum gap between modules. So let me show how this works. So I define this one as a 40 centimeters, then I know what my corner gap is 50 centimeters. So in a simple word saying, I'm limiting software to place the string in one small subarray. I also can define a maximum cable length to estimate and calculate all the gaps between modules. And this one gives for me the initial layout. On top of that, I can change these settings, change how the strings will be applied, and get more detailed stringing. So let's see, selecting the zone where I want to do. With a custom stringing, I can get even more customization. So I can just draw a simple line on the layout. As you can see, it's counting the modules for me. Everyone who done stringing manually know that this is one of the biggest nightmare for the engineers, just to count how many strings you will have. Usually just lost the number and need to redo it. And as you see, it could take just a few seconds. Yeah. So this one is like a more customizable approach, and you need to get the exact result which you are expecting. So then we can do like step by step. And of course, we will guide you even more for the user who will be interested to test it. If you want to do it quickly, you can also define this parameter as a 4 meters between two different modules. Apply this one for the layout. It will take a second, and it will generate the preliminary stringing throughout the layout. We can also change the direction. So it means by changing the direction, we'll get a little bit different output each case, because it starts to do the stringing for a different point. That's why the final result will look differently. Even at this stage, we can easily customize the layout by deleting some modules which we don't want to have it, by extending the string. So for example, here we have 24 modules. Let's say we want to have 26. So we can easily and simply customize this one here. And the similar things we can do, for example, for the string. So just selecting the string. Here it is. Here we go, selecting the string and just extending to two more modules. So let's say we have a string here. Okay. Let's do it like this, and 25. So I want to have a 26. Here we go, 26 modules. Once again, we can eliminate some of the modules which is not necessary. If I see the position where I want to add some additional strings, so I can simply do that. And of course, I can draw like zigzag principle. I can always use the Ctrl-Z button. Let's see if I draw it incorrectly. So this one will allow for me to come back to the specific point. So the tool here trying to become as detailed and as customizable as possible throughout different engineering stage. Okay, let's move forward from the stringing. Let's say this is more or less the layout which we prefer to have. Let's add a few more strings. Oh, by the way, I didn't mention that also every design which was done could be just simply overridden. So as you can see, I'm just drawing a string on top, and software automatically changes accordingly to my new pattern which was drawn. So let's add some additional string at this end. This one goes to the 19 modules, and let's eliminate something that is not really effectively placed for us. Okay, and here we go. So now we can move forward. So this is the layout which you have. This is the stringing. Keep in mind, you can also see the string number on each of the strings for our whole layout. We have a 2 separate string, east and west created automatically. Now, when I said that we can do inverter configuration here. So what the software allows for you to do, it's allowed to set up the MPPT numbers per inverter. So this one becomes really handy because we'll have really detailed design of the inverter itself. Then you can also update all of them automatically. You can do it one by one. So for example, we can set up at the 6 inverter, we'll have just 8 inputs, 8 MPPTs with 2 inputs. When we did this one, we can now do it semi-automatically, fully automatically, or fully manually, the assignment of the streams to the inverter. So let's start from the full automation mode. So the full automation mode will allow for the user to have a full flexibility and override any existing rule. It means that we can set up input number 1, select which specific strings we want to add, and to add to that input. If we want to add a second string, we can do it as well. Keep in mind, in this case, I select one east and one west string and connect it to the same MPPT. Usually, which is not the case if you're not using the optimizers, but if a user wants, this functionality allows for you to have this flexibility. Now, the next step would be to do it in a semi-manual way. So it means we will be capable to select the strings on the inverter level. So let's say we select this portion of the strings. So we have 14 of them. Let's add a few more. Okay, let's say selected this part. Let's deselect these strings. This one. Okay, now we have the perfect exact number what we need, and software automatically assigns string to the inverter. In this case, software assigns the strings, separating the east and west strings to the different MPPT. So we are not mixing when we are doing it in semi-manual way. Once again, just quickly show how this works. We select inverter, select which strings we want to have it. So in this case, I have up to 20 strings. Select the strings, apply the color, and here we go. If we want to speed up the process even more, for example, we have a project, I don't know, 4 or 5 megawatts, something very heavy will show for us. So even this approach could become a little bit tedious. Let's say we want to speed up the work. So then we can enable the functionality to connect all selected strings to the inverters. In this case, we select a portion of the string. So the exact number would be 46. So it's 2 inverters, a little bit more. We apply this functionality. So the third inverter will be fully filled with the strings. Then we have a 4th inverter, which is fully filled. And then the rest of the strings was connected to inverter number 5. Keep in mind, we get the label on each of the string. If you need, you can easily customize the label as well. Just change, let's say, what we will have here. Inverter number, and maybe some additional string number. Okay. So just like that, it could be customized. Once again, let's say here we want to fill up this inverter by adding a little bit more strings. So this is exactly what we continue doing. Selecting this portion of the strings, it was connected. We can do a few more based on the capacity. Okay, 227, and we add 2 last strings. Wonderful. Now the rest of the strings will connect to the last inverter, and we will finalize our MPPT configuration step. As output of this step, engineer can print out the MPPT connection table, which will give for you understanding about the inverter number, MPPT number, input, the string connected to that specific input, and of course the string size. Majority of the strings will be 24 modules, unless those we manually customize, we have like 20 or 26 modules. From here, we can go even deeper. We can draw all the cable trays on the drawing by automatically sizing them, or just by setting up the size manually. It depends if you want the software interact with us here or not. So basically what the software will do, based on the cable quantities in it will change the size throughout the drawing. So now I just enable the cable tray sizing option. I draw where my cable trays originally should be placed. So for example, one cable tray here, another cable tray will add on the segment. So let's connect them at this point. Okay, let's say the third cable tray could be done here. And let's see, one more we will add somewhere here. Okay, let's do one more vertical cable tray. Let's go from this end and then next to the safety path to reach the final. Okay, now for majority F area, we have a connection patterns. Just adding one more cable tray, let's say at this point. Okay, so let's see, this is a cable trace which we will be using to create our design. The approach is really simple because we can enable the software to allow cables to cross the safety path if needed, and of course we can enable for them to avoid induction loop. To generate the cables, you just need to click one button, create the cabling, and this one will take a few seconds. It will generate all the cables. All the cables, this means that we'll have a connection from each positive and negative poles, or positive and negative terminals, it depends how we call them, directly to the inverter level. So just this step could save, I would say, 50 to 60% of manual work. Also, each of the cable becomes a 3D element, so we evaluate the connection point, the table height, and all the similar things. Additional comment which has to be mentioned is when the inverter is not on the building, but for example, inside the building or on the wall outside. So we also will draw a 3D cable to that point too. As the result of this step, we can produce a single line diagram of all the elements which we have up to this point. So you will have inverter, you will have MPPT, you will have each of the input. As you can see, this is a string name, but it will be easier to see. And then we have a cable length in meters from positive pole or terminal and to negative pole or terminal. Also, all this data, which we have designed up to this point, is in a 3D. So everything what we have added is a 3D elements. It takes into account cable trays, cable itself, modules, inverter. So that's why it's a full 3D design, which you'll have in AutoCAD. Of course, you can print out, you can copy, you can print out the whole drawing, you can just print out the specific part. So this one, we rely on AutoCAD functionalities to provide the printouts of the drawing. What we provide for PVcase side is the bill of material. So we can find this one through the layout information. And there's an option export everything to the Excel file. So export bill of material, and this one generate the Excel file where you will find all the necessary information. Okay, let me just create this Excel file, and I think I will need to reshare my screen. Yeah, okay, now you can see this one. So just give me 1 second. Let me stop sharing my AutoCAD screen, and I will share my Excel sheet. Here we go. Now it should be visible. So what we get in the Excel. So first of all, we get the total capacity. So this drawing which we done has 1.5 megawatt. Not really small, but quite decent project, taking account that it takes for just about 20 minutes to do that. Then we have a module power. So we have 540 watt module. When we have the module name, so this is all the dimension of the module. In addition to that, we have a really detailed list of each of the cable tray. So let me explain how does that work. In our drawing, I will show you just in a second, we will have a cable tray numbering. So it's mean that each of the cable tray has a unique number, and the cable tray basically is divided in a segment, which is a 3 meter length. And that segment will list all of them accordingly to the size, or we call it width. So accordingly to the size, all of them will be listed here. You will see the total quantities. And usually we get the question, so why the list is so long? Because some of the cable tray, like, let me just mark them with a different color, is not exactly 3 meters. Because when we're dividing the specific distance to 3 meters, usually we have some smaller, and so that's where we indicate each of them separately, that the engineer could make a decision what to do. Maybe we'll increase some of the size of the existing these cable trays. Maybe we'll, instead of buying 2 different cable trays, we'll buy 1 cable tray at this point. So that's why this functionality allows quite easily to maintain and reach that goal. From here, the other thing, what we exporting as a bill of material is in the electrical design. So we will have inverter, each of a string added, each of the optimizer, each of a module quantity in the string added. And then we have a cable length. So there's 4 different cable length provided here, and let me explain each of them separately. The first 2 is quite simple. Cable length from positive and negative pole. You already saw this one in SLD, so the same we have here. The addition on top of that, you have a cable length on the string. So this is a cable length which we need to connect all the tables from positive to negative pole. In some cases, the original cable which came up with a module won't be enough. For example, we have a 1 meter cable length which came up with a module, and it's not enough. So that in those cases, we'll need to add the extensions or the jumpers. So this is exactly what we have in the extension tab. You have the additional cable which you will need to cover your stringing. And each of this extension, it's marked in the drawing as well. So we're doing this on per string level. Here we accumulate the total length, but in the string we have each of them provided separately. So this is more or less how the AutoCAD works. So just coming back quickly to my AutoCAD file, because I just want to share a few things what I mentioned I didn't show you yet. Okay, here we go. Now it's visible again. So this is what I mentioned about the cable tray number. So we can see the cable tray number on each of them, 48, 47, 46. This is the size of a cable tray. So this is a 55 millimeters. And this is a cable quantity unit, 54 cables. Let's see, here we have 42 cables. Of course, each of them could be edited if needed. So here we also provide a full customizability and input from the engineer side. Let's say I want to increase the size of this cable tray. So I can easily view it, re-export this one to the Excel, and I will get the new layout. And this would be, yeah, I covered this part. Now, what I want to show for you once again is the extension or the jumper. So this is the jumpers. We can select all of them throughout the drawing, and we will see the total quantity of them. So in this specific project, we will need to add 66 jumpers or 66 additional extensions, because our cable length, which we use, was not enough. Just to clarify, we used 1.2 meters. So this is more or less how a product works, what the capabilities it has. And I know that you guys have some questions in the question bar, so I hope myself and Heidi will be capable to answer them. Okay, let me stop sharing my screen. here we go. Hayden, maybe any comment or question from your end, because I know what you even using the software, but always when you're seeing one more time, so maybe something came up and something you would like to highlight.
I honestly have no comment, Tadas. You did a very thorough summary of it right there.
Okay, wonderful.
Yeah, that was really informative, guys. Thanks. I've got, so in terms of the questions, there's a few that we were going to ask from PV Tech side, and then we're going to turn to some audience ones. So if anyone has any more audience questions, stick them in the box. We don't have too long left, but I think we can get to a good number of them. Tadas, I wanted to ask you first. I think you touched on this maybe, but can you make different iterations of the same project inside PVcase?
Yeah, so we already touched a little bit this base, but the iteration, I think, as Heidi mentioned, it's quite important thing that you need to prepare a few different layouts. So yes, you can definitely do it. This one you will be capable to do it through the layout information section. I already showed this one, so just want to repeat that you will find this in the layout information, and each of the project which you will done will be capable to regenerate at any point, and even all the electrical design will be saved. So it means if you design something, you want to come back to your previous drawing, everything what you've done up to this time will be saved. Okay,
yeah. And on the subject of electrical design, what limitations are there for electrical design?
That's a really good question about the limitation. So regarding the limitation, I think the main one which we have is we are not running any calculation. As you saw, to this point, we're not using any database. So basically, it has to be defined the main inputs from the engineer side, and we are not checking the compatibility. This is something what we will develop and will add in the future. But for now, we rely on the input, which was provided by the engineers, not calculated by the program.
Okay. Heidi, I wanted to turn to you as well. Has your design process changed, or is it affected by safety measures when you use PVcase?
Yes, definitely affected by safety measures. Some of the points I've already hit and Tadas has talked about is adding in those drive aisles. Those are key on a rooftop design, and PVcase makes that so much easier. And then another topic I touched on was the rapid shutdown devices, and designing in a way where we don't need to use those really increases the safety on our sites and gets rid of an entirely risky material. Yeah. So safety is very important in my design process.
Yeah. Okay. And if you're analyzing a rooftop that's heavily obstructed, what does your process look like there? How does it differ from a normal one?
Yeah, so in a normal one, I'll just immediately start outlining all the obstructions and sort of getting their height information. But on a more obstructed roof, I'm trying to look at the distances between obstructions, what kind of height they have, so I can sort of see, is their shadow going to be really large? Is that going to take up most of this open space? And sort of just analyzing how big any like open spaces with no equipment and no obstructions is to see how many modules can we realistically fit on this rooftop.
Okay. I was just going to turn, we had an audience question just come in from Francois asking, is there any calculation report for cable loss and the sections for the AC electrical protection?
Yeah, that's a really good question. So currently we are not covering the losses or the voltage drop or in the AC part or the DC part. The software itself is more dedicated for the design stage. So it's going to design and create the layout in a way as it would be usable, and it will be really easy to calculate the proposal or later on to move to the detailed design stage. So usually the calculation and losses part is covered by the PVsys. So that's why we have a fluent exportation from our product to the PVsys. Because we are based in AutoCAD, that's why it's limiting for us to make proper calculation due to its computation capacity. That's why majority of our customer as Engie, for example, using the PVsys to make that part.
Okay. On that subject of AutoCAD, we had another question. Is the software compatible with AutoCAD LT?
Yeah, so right now it's not possible to make it compatible with AutoCAD LT. The main limitation is that the AutoCAD LT doesn't have a capability to work with 3D elements. And as you saw, everything what we done with PVcase, due to the precision proposed, we are doing in a 3D. So it's compatible just with a full version of AutoCAD. It could be AutoCAD Civil, it could be AutoCAD Electrical, AutoCAD Maps also work, but AutoCAD LT is one exception which we have right now.
Okay. Another one for you, Heidi. I wanted to ask about, so obviously PVcase calculates shading. Before PVcase, how did you do that? How did you calculate the shading?
Right. So the process before PVcase was much more of a educated guess, I would say. Definitely a decrease in accuracy. We had an example map of shadows sort of in different locations over the country. And what I would need to do is get that shadow box and sort of scale it to whatever the height of our obstructions was, and then just kind of guesstimate of what direction that shadow is going to be going and placing those markings that we had on the map. So it was very much just an educated guess of like, we'll get as close as we can to this area and see what the shadow is supposed to look like. And we were guessing where the shadows were going to be placed. So this has really increased our accuracy on that.
Okay, nice. And Tadas, following that, could you explain how PVcase can help evaluate yearly shading losses?
Yeah, so this one is an amazing question. So this is something what the team right now working on. At this point, we evaluate the shading losses based on the sun position angle as a show for you representation. But what we learn from our customer who helped us to develop the product is that usually we are looking not to the specific like shading angle, but we also want to understand what the shading losses, especially from irradiation point of view, we will get on the modules. So we already developed the feature which will allow to see the shading losses in the percentages throughout the whole year. Right now, the team finalizing just the user interface, and in the next few weeks, this feature will be available. Basically, as a final result, it will show the shading losses in the percentages across all the year. And the data of irradiation losses will be taken every hour. So algorithm is quite powerful, and this will provide quite detailed numbers.
Okay. On the subject of covering a whole year, Heidi, to turn to you again, what kind of projects are you designing most during the year, over a year?
Yeah, so our business unit of distributed solar and storage does all kind of projects with rooftops, ground mounts, carports, some that are just battery storage, but definitely most frequently I'm doing rooftops. I said earlier we're proposing over 200 rooftops a year. I'm working on at least 2 or 3 rooftops every week. So that is.
Oh,
it looks like we lost that lady. I hope this is not the energy shortage.
Yeah. Okay, yeah, I think we lost Heidi. Hopefully she'll be able to rejoin us for the last few minutes. But another question then for you, Tadas, is about. Oh, there you go.
Sorry about that, guys. Lost my internet connection shortly.
That's okay. So we just had a question come in from the audience. Does PVcase suggest which panels might need optimizers based on the shading that might occur?
So no, so currently this one should be selected and indicated by the engineers is do not offering like suggestion or something like that. What we will have in the future together with our shading analysis implementation, so we'll continue to work on that one, maybe not suggesting what optimizers to use, but more allowing for the customer to optimize the layout. So it's mean the next step, what we are planning to do in the product is to provide the early estimation of energy production by generating 2 different iterations and seeing what the impact it will has at the end. So it's mean you don't need to go to the PVsys export every time the preliminary numbers user will be capable to get in the product. This is not exactly related to the question which I asked, but I just wanted a little bit explain on this topic. Basically, we software right now don't do the suggestion. It's provide the information based on the input which was added from a customer point of view.
Okay. I wanted to ask as well about if the product will have the ability to design a mounting structure.
Yeah, so this is a really good question. I think majority of participants who was watching saw what I didn't add any mounting structure at this point, because to implement the mounting structure, we have a plan to work with the main mounting structure provided in Europe and USA. So it's K2 system, SDEC, and Unirac. So this is like our target companies they have integration with. We already working closely with SDEC and K2 system. So it's till the end of the year, we'll have an option not just to design, but we'll be capable to select the system and get the ballast report as a final result of that.
Okay, nice. And then I suppose, can the software provide an energy estimation for a year? And then how do you access the data for a year for your project?
Yeah, so currently it can also be done. So as I mentioned before, right now the main principle of this one is to use with PVsys. So the layout could be exported to PVsys and to get the report here. But the next step, what we are working on together with our PVcase yield tool implementation, is to get these preliminary numbers directly in AutoCAD.
Okay. I suppose we'll start wrapping up unless there's any more questions from the audience. One I saw was, to clarify, does PVcase have a library of panel models and inverter models that you can choose from?
Yeah, in this case, the library is not really necessary because we are not running energy calculation like of a cable size or the voltage drop. So this one will come up in the future where we'll implement this calculation. Right now, we basically need just a dimension to understand the main principle, how exactly to place these modules and what dimension to use.
Yeah, okay. So I think unless there's any more questions coming in from the audience, we have probably covered what we wanted to cover. Anything else you guys wanted to mention?
Maybe just from my side, I really want to thank everyone who was attending this webinar, and especially for the questions. We had so many questions and some amazing questions. So thank you very much, everyone, and especially actively participating in this event. I'm really happy to be here and to present our tool and our solution for you.
Yeah, it's been really great. We've had great attendance. Yeah, the questions have been really switched on. And I'd like to thank you, Tadas, and you as well for coming here and giving such an interesting and informed webinar.
Yeah, thank you, Will, for having us and for hosting it so well.
Great, no worries. Well, yeah, thanks everyone. And as I mentioned at the start, the webinar will be available on the PVtech website shortly, and the YouTube channel. And if you have any more questions, PVcase are happy to answer them for you. So thanks everyone. And I think that's us. Thanks very much, guys.